Hello students, today we are going to discuss about an important rule related to Diels Alder reaction, that is Endo rule for Diels Alder reaction. As we know very well, Diels Alder reaction is a 4 plus 2 cycloaddition reaction. Here you can see a 4 pi fragment that is diene and 2 pi fragment it is dienophile, and it will undergo 4 plus 2 cycloaddition reaction. You will end up with a cyclohexene. Okay, these two are newly formed sigma bond. This is a rearranged pi bond. So when we are discussing about the Diels Alder reaction, electron donating group on diene will enhance the rate of Diels Alder reaction. Electron withdrawing group on dienophile will enhance the rate of reaction. The main selection rule regarding with this reaction is it is allowed only under thermal condition, and electron rich diene preferable for this reaction, electron deficient dienophile preferable for this reaction. Okay, while we are discussing Diels Alder reaction, we can see two types of Diels Alder reaction. One is irreversible Diels Alder reaction. So in this scenario, here we are discussing Endo rule. So the Endo rule is more pronounced under irreversible Diels Alder reaction. For time being, we are considering cyclopentadiene as a diene, maleic anhydride as a dienophile. Okay, so we can see two situations. Let us discuss the first situation, that is this classification is mainly dependent upon the approach of dienophile with respect to diene. This situation, that is Endo approach. In Endo approach, your dienophile approach with respect to diene in such a manner that their carbonyl group present at inward position. Okay. The most important thing is that during the transition state we can see an excess interaction, that is interaction of HOMO of carbonyl group with respect to the LUMO of olefin present in diene. Such interaction is called secondary interaction, that is a stabilization interaction. The most important thing is that if you have a dienophile having carbonyl group, it can undergo secondary interaction, that is a stabilization interaction. As a result, you will end up with a nice product in which your dienophile portion will be downward. Hydrogen is upward, dienophile will be downward. That's why it is called a Endo product. Endo product with, that is, it is far from the bridge position. So this is your Endo product, and it is Endo product is mainly kinetically controlled product. According to Endo rule says that in a irreversible Diels Alder reaction, your Endo product will be the exclusive product or the major product. But this Endo product is less stable. So we can discuss why it is less stable while considering next situation. Next situation is exo approach. In exo approach, your dienophile portion will be outward. As a result, you will end up with this product. In this product, your dienophile portion will be upward. You can see hydrogen is downward. Okay. So this is your exo product, and this exo product is thermodynamically controlled according to Endo rule. This is minor product. Interestingly, it is more stable. Why your exo product is more stable than your Endo product? Listen, your Endo product having extra steric hindrance between this dienophile portion and this hydrogen. Steric hindrance is a destabilization phenomena, but you can't see any such kind of destabilization steric hindrance in exo product. That's why exo product is more stable than Endo product. Okay, I repeat, this Endo rule says that in an irreversible Diels Alder reaction, Endo product will be the major product. Okay, now we are moving to next category of reaction, reversible Diels Alder reaction. Actually, it is a exceptional case of your Diels Alder reaction. For time being, we are considering furan as a diene and maleic anhydride as a dienophile. Clearly it will undergo Diels Alder reaction. You will end up with a kinetic product, that means endo product. Endo product, your dienophile portion will be downward. Since it is reversible reaction, further it will undergo retro Diels Alder reaction and you will end up with the starting material. Again this starting material undergo Diels Alder reaction and you will end up with the exo product. This exo product is thermodynamically controlled product and it is more stable product. The thing is that why this product is formed, since we know that exo product is more stable than that of endo product. So in a reversible Diels Alder reaction, your exo product is the major product. So it is exceptional case, it is contradictory to endo rule. But the thing is that if your Diels Alder reaction is reversible, remember that your major product will be exo product. If your Diels Alder reaction is not reversible, your major product will be endo product in accordance with the endo rule. Okay, so clear? Now we move on to an example. This is the question. This is your diene, this is your dienophile. So find out the major product with the stereochemistry. While discussing the stereochemistry of Diels Alder reaction, so this is a general diene, this is general dienophile. So I have 4 kind of substitution. 2 are inward substitution, 2 are outward substitution, and this is your dienophile having carbonyl group. So if your dienophile having carbonyl group, it will obey endo rule. Okay, if it is irreversible. So after this reaction, you will end up with a cyclohexene, but the stereochemistry is that your inward group, that is C and A will be in wedge. Outward group A and B will be dash. And according to endo rule, your dienophilic substitution, that is carbonyl group, will be in downward. So the whole stereochemistry will be like this. In accordance with this general trend, we can answer easily our question. So after this Diels Alder reaction, you can have this cyclohexene. So since your methyl group in outward, both are in dash, and in accordance with the endo rule, this aldehydic group will be in dash. Okay, clear? Okay, thank you, take care.